We will discuss about deep learning in this particular session. We will have the discussion about what is meant by ML, what is meant by deep learning, how they are differing from each other. Then what is the deep learning, how deep learning is different from the machine learning. So we'll have some discussion over it. So we'll have the discussion first about AI, ML, deep learning. So today, many of you are in this particular field, people will understand or they will have some idea about the AI, ML, and deep learning. We know that AI is in the boom. AI is in the boom. So AI, ML, deep learning, data science. So all those things, all those terms are very much popular. Even the job profiles with related to AI, ML, deep learning, DS are in the boom. Now, what is the AI? First of all, just basic. What is the AI? Then we'll go towards machine learning. Then we'll go towards deep learning and data science. So, what is the exact difference between them? So, first, what is AI? What is AI? So, it is nothing but artificial intelligence. AI means artificial intelligence. So in case of artificial intelligence, it is nothing but the application, or it is nothing but some form of something which can do the task by itself or own by own. It is not a means like a human intelligence. For example, human intelligence. So human is performing the task based on whatever inputs the human being having. So artificial intelligence is nothing but the machine or computer can perform the task by its own without human intervention. Without human intervention. So we are not taking any human being in between, and that is nothing but you can say application which can perform which can perform. So I will change my color of these, which can perform task by its own and without human intervention. Without Now, what are the examples of AI? You know that, for example, Sophia. So, Sophia is the robot which can perform, which can give answers, which can do many things by its own. So, if you ask something, then Sophia will reply. Similarly, you have heard about the self-driving cars. So, self-driving cars, those cars can take the route without human intervention. Without human means human is not driving the car. The self-driving car will take input with different devices, different sensors, and based on that, it can act accordingly on the roads. So, this is the example of AI. Now, AI is the bigger thing. AI is a bigger thing. So if we draw something like this, something like this, so this term is known as AI. Suppose AI is a superset. AI is a superset. The next term is a machine learning. Now, what is machine learning? So machine learning is generally taking a data, and processing a data and analyzing it. Processing a data and analyzing it. So most of the times machine learning will have a structured data, most of the times, or unstructured data. It will take a structured or unstructured data. Structured or unstructured data. Data and process it. And what about the deep learning? Deep learning. So deep learning, again machine learning is a subset of AI. Machine learning is a subset of AI. So we can draw this like that. So it is suppose ML, machine learning. Now deep learning is subset of ML. This is a subset of ML. So this inside part is known as deep learning. So what do you mean by deep learning? So deep learning will take any type of data, structured or unstructured data, and it will try to mimic the human brain. So deep learning will try to mimic the human brain. Mimic the human brain. So it will have the neurons and all. So in the human brain we have biological neurons, and based on the inputs whatever neurons are having, the human brain will process and will give the output. Now here is the definition, a more elaborated definition you can have. Now what is the AI? It is a scientific field which concerns with the development of algorithms that allow computers to learn without being explicitly programmed, and your computer will take a decision, own decisions. Similarly, what is the machine learning? It is a branch, it is a subset of the AI which focuses on the methods that can learn from the data. So we know that in the machine learning we have various types of data. From the data we are finding some patterns, we are finding something, some equations or some patterns, and based on that we'll do the prediction. So this is called as machine learning, and machine learning is the subset of AI. Now what is the deep learning? Again, deep learning is a part of machine learning, and that uses many layers, and it will mimic the brain. It will mimic the brain. So that is nothing but the deep learning. Now what is meant by data science? Again, one concept comes as a data science. So you can say data science is a combination of many things. It will have a NLP, it will have a AI, it will have ML, it will have a DL, as well as it will have the statistics as well. So it will be nothing but like that. So you can draw this as a data science. So data science is a combination. It is a combination of many things. It is a combination of AI, ML, NLP, deep learning, statistics, etc. So this is how AI, ML, deep learning and DS has. Now our focus is on the deep learning. So how we will have the systems which can mimic the brain. What is meant by mimicking the brain? Means the artificial brain. It is not the actual brain, artificial brain. How we can have the artificial brain with the like in the brain we have biological neurons, biological system, and in the deep learning we have artificial neurons and artificial system for processing purpose. Now, what are the different applications of deep learning? What are the different applications of deep learning? So, deep learning is the term which is having very much of the boom, very much of importance nowadays. So, where we can use that this particular deep learning? First is speech recognition. I will explain you what is the speech recognition. Then automatic machine translation. Then instant visual translations, object detection, object classification, object identification, and so many things. So deep learning having so many things. We will take an example of few examples where we are using a deep learning, and you can say directly or indirectly many people are using a deep learning. They are the users of the deep learning. First we'll have example of chat gpt. I think the childs to the older people, they are using a chat gpt, and means indirectly they are the users of the deep learning. First application is speech recognition. What about the speech recognition? So speech recognition is nothing but the system which will detect the a person's voice based on his input. If suppose for example I give the input of the XYZ person, then that system, whatever design system, train system, will detect that person. So it is nothing but a speech recognition. One more application I will tell you. Nowadays, one more application is in the boom, that is nothing but the audio processing. What is the audio processing? For example, if suppose I have XYZ person or XYZ person, and or it is a famous person, then I can, whatever script I have, whatever text I have, I can convert into that particular sound. I can convert that text into the sound of the famous person. So that is possible today with the help of deep learning. Another thing is one more incident happened a few days back. So there is a strike of the voice artist in the US. Uh, Strike of voice artists. So why they have strike? Because there are systems coming in into existence. Those systems are replacing the artist. What is the work the artists are doing? AI means voice artists are doing. They are giving their voice to the characters. They are giving voice to the characters, means animated characters or in the movies. And now the AI is replacing those particular artists, because AI can generate the audio same like them. So that is nothing but the example or application of the deep learning. Not replacing of that, means I want to tell you, the AI can generate the voice. So this is one application of the deep learning. Now next is automatic machine translation. You might have used the Google Translator. Google Translator. Now what is the Google Translator is doing? If you give the text in any of the means, if suppose you are entering a text in English, then you can convert into Hindi. It is possible. English text you can convert into Hindi, or you will have any language text and you can convert into any language. So that is nothing but the translation, and automatically machine can do. So this is nothing but the based on the deep learning. Now next, a visual translation. Visual translation. So you can have the visuals and you can find the meaning out of that from this one. Then you will have the object detection. Now what is object detection? The object detection, for example, I will tell you what is the object detection actually. So in case of object detection, you can detect what particular object is available in the photograph. For example, if the photograph is having a cat, dog, then you can identify the where is the cat located, where is the dog located. So object detection is possible. Even object detection is useful in finding how many humans are there. Or one example is which means, for example, in the offices, for example, we in the offices, sometime we will have the cameras, and in front of the camera, if we stand, then the camera or the system will detect who is that person, and based on that access will be allowed. So this is one example of object detection. Similarly, we have many other applications of deep learning, like image classification. Image classification. Image classification. Then example of chat gpt. Chat gpt can perform many things like question answers. You can ask any question, and based on that, chat gpt can give the reply. So this is nothing but how applications of deep learning. And why it is means there are the many applications, not only limited to this. Again, one more thing I would like to explain you about deep learning. Why deep learning is popular today? Why deep learning is popular today? Deep learning is popular today. Why it is so? So there are few reasons out of that. So why deep learning is popular? First reason is there is a generation of lots of data. First reason is generation of lots of data. Lots of data. Now you might have the Facebook account, you might have the LinkedIn account, you might have the Instagram account. Now you can understand how people are uploading a data, or uploading a photograph, or uploading the post on the Instagram. Daily few people are uploading two, twice, thrice, fourth, and you can compare how much data is generated. This data is in the petabytes, and means huge data is generated. Now if you are generating a huge data, what is the use of that? What is the use of that? If you take that data and if you process that data, you will find something out of that. For example, one simple example I will give you. On the Facebook, people are making comments, or some websites like Amazon website, Flipkart website, people are making some comments, that is, this product is good, how I feel about that product, this product is not good, and finally you can analyze sentiment out of that. You can analyze sentiment out of that, means how this product is good or bad, or from the Facebook, based on the comments done by the people, you can identify the person is positive or negative. And there are so many applications nowadays, those are taking a data and analyzing it and processing it. You might have the idea that if you search something on the Google, if you search, if suppose I want to buy, or I am searching for the laptop on the Google, then everywhere on your Facebook account link, means on some websites, you will get the notification about the laptops. So what it is, so Google is tracking your data, Google is taking your data, processing that data, and based on your interest, Google is trying to personalize your data and gives the output or gives the predictions or gives the notifications. So this is nothing but the first thing that deep learning is popular, because what is the deep learning? It performs operations on the huge data. Again, deep learning is used for the huge data. Huge data. Again, deep learning can be used on structured or unstructured data. Structured or unstructured data. Then what is the second reason to be popular? Now suppose you have a data, you have a huge data, but how you can perform the processing? If you have a laptop of Pentium 2, Pentium 3, will it be possible? In the Pentium 2, Pentium 3, even opening a website, it is a difficult task. It is a difficult task, tedious task. But now you have a processors with the high computational power. You have the good processors, very good processors. Again, you have a GPUs. Have you heard about GPUs? GPUs means graphical processing unit. Graphical processing unit. So there are some examples of GPU like NVIDIA, GeForce. Then you have ATX Radeon. So such type of GPUs are available, and those GPUs can perform the operations very fast because they are assisting your processor available in the system. Again, you have a very good RAMs and very good infrastructure. So that is the one more reason that deep learning is popular. First reason, main reason is generation of lots of data. But only generating lots of data, it is meaningless. You have to find, you have to perform some operations on that. You have to find some information out of that. So how you can process it? You will have the infrastructure. So good processors are there. You have GPUs, you have TPUs. One more thing is TPUs. TPUs means tensor processing unit. Tensor processing unit. They are assisting your processors and having the predictions. So this is how, why deep learning is popular. We have discussed few things about the deep learning. First is, what is the difference, basic difference between AI, ML, deep learning. What is the data science? How they are related with each other. They are not different. They are related with each other. One is subset of another. Second is subset of next. And what is AI? It is application which can perform task by its own. Machine learning, it can take a data and find some patterns, find some predictions. What is the deep learning? It can try to mimic the human brain to perform some operations. In case of machine learning, basic difference between machine learning and deep learning is, machine learning will mostly perform operations on the structured data. Now, do you have the idea about the structured data? So structured data is nothing but the data which is stored in the form of columns and rows and columns, or in the tabular format. Unstructured data means it is not stored in the tabular format. For example, images is the example of unstructured data. Audio is the example of unstructured data. Your text, whatever generated, it is the unstructured data. So deep learning can process any data, structured or unstructured. Deep learning is mostly taking unstructured data, and based on that we are performing some operation. One more important difference between machine learning and deep learning is, machine learning will process a data, so that data in that data you must recognize, or you must separate out the features. If you give the features like independent feature, dependent feature, like x1, x2, x3, or any independent features and dependent feature, so you have to identify those features. Try to identify the features before starting a training. But in case of deep learning algorithms or deep learning models can identify the features also. You have to provide a data directly to the deep learning model. Deep learning model internally will perform some operations to find out the features. It will extract the features and then it will again train and you will get the output. So that is the main difference between deep learning and what you can say machine learning. So here is one difference you will have. So here machine learning, you will have input and you have to extract the features. You have to extract the features. What is means the independent feature, what is the dependent feature. You have to give the separate things in the machine learning, and then it will perform the classification operation, and it will give that output as a car or not a car. For example, it is a classification. Classification, there are regression and classification. You have learned more about that. Regression regression and classification. You have done some clustering as well. But regression means, what is a regression? Regression is nothing but you are trying to find something or line which can best fitted for the data, and based on that you will predict the value in the regression. What is the classification? Classification will tell, if suppose there are three classes like a car, truck and bus, and based on the data you will predict the class, whether this particular data is related to car, whether this data is related to bus, whether this data is related to truck. So you are making a classification. So regression and classification. But in case of deep learning, you will have input. Here you can find input, then features and the classification. Everything will be done inside the deep learning model. You need not to separate out the features. So that is the basic difference between deep learning and deep learning. Again, one more difference I told earlier, that is machine learning mostly requires structured data. It can perform on unstructured, but like images, it cannot perform operations on the images. It cannot perform operations on the audios and all. But deep learning can process. So deep learning can take that data, it will perform the operation, and it internally it will find the features and it will have the whatever operation you have to do, classification or regression. So here the examples are: no need for manual extraction of the features anymore in the deep learning. Then deep learning models will continue to improve as the size of your data increases. So deep learning models, the accuracy of that will improve based on your data. If you are increasing data more and more, the deep learning model will have the accuracy, more accuracy. So you will have the more data means more reliability and of course better accuracy. So this particular thing I feel personally that deep learning models need a data, because in one problem statement we have to find something. For example, the human part, xyz human part, we have to identify. Then initially we have trained our model with data 1000 2000 data only, 2000 images, but the accuracy was not good, because whenever you are going with the production, means you are as a product, your accuracy needs to be reached to 95%, because you will find it whenever you want a production level product, production level things, your accuracy should be up to 95%. And how you can increase the accuracy? With any model, means machine learning model or deep learning model, but mostly I am talking about the deep learning model. You have to increase the data. And what about the data? Data should be means what rules should data should follow? What read means rule data should follow? First is you require the large data set. Now second rule must be keep in mind. So data should have a variations. What are the variations? If suppose I have images of a human being and I want to find a particular thing from that image, the variation is nothing but lighting conditions should be different, background should be different, different people with different clothing things. So that is nothing but variation, and the variation should be lot of variations. Then this data should be balanced. You know about the balanced data. What is balanced data? Means each type of data should be equally available in that particular data set. So large data set, then variation should be there, balanced data should be there. So if you follow this thing, you will get a better accuracy. You will get better accuracy. Then for getting a more accuracy, you have to use the more training, lots of training. Then so those are some things you have to follow. Are you getting my point? What I want to say, if suppose you want better accuracy in case of deep learning, you must have a large data set with variations, and it should be balanced data. It should be balanced data. Again, you can improve the accuracy by changing the hyperparameters. One more thing you have with this as a hyperparameters, and you are very much familiar with the hyperparameters in case of machine learning as well, because machine learning algorithms can improve their accuracy with the hyperparameter changing or modification of the hyperparameters. So try to understand actually what is a deep learning. Deep learning is nothing but a training a machine like human, because machine can't learn everything in the one iteration. For example, today I am telling you about deep learning, right? But this thing is very much new to you, so you will understand out of 100% maybe 10% or maybe 5%. This is our first iteration. Whatever sessions I am going to take, I will teach you deep learning. I will tell you some concept explanation about the deep learning, and this is the first iteration. In the first iteration, it might happen that you will get only 5 to 10% of the out of this 5 to 10%. Now how you can increase your knowledge in the deep learning to 100%? Even 100% is not possible. 90%, 80%, by iterating over it, means making things again and again. You will learn these things again and again, and you will understand, you will get the understanding of deep learning 85%, 90% with the different or many iterations. With many iterations, if you are taking many iterations, then definitely you can understand deep learning better. Not I am telling means completely, but you will understand it better. So this is how I want to train you as a human being. So similarly, you will have the machine training. So you can train the machine with the different iterations. So in first iteration, machine can understand something. Then next iteration, machine can try to understand better out of that data. In third iteration, machine can understand more and more. So there is a concept known as epoch. So this concept I will explain you later. So it is nothing but iteration wise training. You have to iterate over data again and again to learn more about the data. As like I told the example, deep learning, you can understand 5% or 10%. You may miss in this particular session, you may have idea about the few things only. But if you iterate over these sessions or iterate over deep learning concept again and again, you will definitely understand what is a deep learning in a better way. So this is how we are doing a training, doing a training. So this is how a human being can be trained and how deep learning can be trained. Now what is a perceptron? This is what we have as a perceptron. This is what we have as a perceptron. I will draw this. I will explain you better way. Now what it does, if suppose I am having a single neuron, this is suppose single neuron. Now in case of deep learning, how this neuron will work or how the perceptron will work. Now it will have inputs. Yeah, definitely as a human being, we are taking inputs through eyes. We have various senses, right? Like touch sense, we have smell sense, we have taste sense, we have eyes to visualize it, and based on the inputs, our brain can do the operations and will take the actions. I will relate the example later. Suppose this is a neuron, single cell, a single neuron. It may have input if suppose there are three inputs, you can say input x1, input x2 and input x3. There are three inputs and this neuron will have output as a y, will have input as a x1, x2, x3 and output as a y. Now how this particular cell or neuron will act over this input? So in case of deep learning, this all the inputs will be multiplied by some weight. For example, the x1 is multiplied by weight w1, x2 having a weight multiplied by w2 and x3 with the w3. Now this particular neuron, what it will do? It will add all the inputs multiplied by the weight. All the weights multiplied by the input. So what is the multiplication of that? It will become x1 w1 plus x2 as an input w2 plus x3 w3. So it will multiply the input with the weights. Multiply with the weights. Now it is nothing but we can write it as a summation of I is equal to 1 to n xi wi. We will write it in general, right? So this is nothing but the first part of the neuron, the first operation of the neuron that it will add the input multiplied by weight. So this is the first thing. Now the neuron, in the neuron you have to apply the bias as well. For example, bias is b. You have bias as a b. Now the final operation will become summation of xi wi, means summation of the weights multiplied by the input plus bias. So here finally it will become bias. Okay, so this is nothing but the output. Suppose for example sigma is equal to summation I 1 to n xi wi plus b means bias. Now in the second part of the neuron, what will happen? First part you are getting that every neuron this particular operation happens. For every neuron, this is known as neuron. For example, neuron, in every neuron or every perceptron this particular operation happens. In the first part, that it will sum or it will add all the inputs multiplied by the weights. So this particular link, you have the link having the weight w1. W1 means any number you have. You can initialize with the 0 as well in the deep learning models. Now after initializing weights, what you are doing? x1 multiplied by w1, x2 multiplied by w2, x3 multiplied by w3, and you have to add it. After adding, there is one more concept known as bias. So you have to add a bias for that. So this is the first part or first operation in the first part of the neuron. Now after performing this, what the second thing the neuron will do? So in the second part, neuron will apply activation function. Now what is the activation? Which are the activation functions? There are many activation functions, but here we are trying to use the sigmoid activation function. And you are familiar with this. What is a sigmoid function? Sigmoid is such a function. It is, yes, it is value is between 0 to 1, and we can write it as, suppose sigmoid is equal to 1 upon 1 plus e raised to minus x. It is, suppose y is equal to, for example, y is equal to 1 plus e raised to minus x. So this is the sigmoid function, and you can apply the sigmoid function in the second part as an activation function. Here you can apply sigmoid function. You can make it as a z, for example, z. Now you can apply this sigmoid, suppose let activation function. You can have activation function as, suppose, sigmoid. You can apply this over summation or apply over the z. So based on the application of the sigmoid function, this neuron will fire, or neuron will give some output as a 0 or 1. Output as a 0 or 1. So this 0 or 1, it is based on the activation function, because we are using sigmoid function, and sigmoid function will have output as a 0 or 1. This particular sigmoid function you have used in the logistic regression. I think you have idea about the sigmoid function, and you have used in the logistic regression. See, this is again more elaborated. First, you will have inputs x1, x2, x3, x4. Then you will have a weights w1, w2, w3, wn. The first part of the neuron, this is the first part of the neuron where you are performing some operation, means summation of xi multiplied by wi, means weight multiplied by input. And you have some bias as well. You have to add bias. After doing this operation, it will be given to the activation function. Activation function. And based on the activation function, your output will be 0 or 1 or any output based on the activation function. But here we are discussing or using the sigmoid activation function. So sigmoid activation function will have only two outputs as a 0 or 1. Why it is 0 or 1? For example, 1 upon 1 plus e raised to minus x. Suppose x is equal to 0. What is the output? 1 upon 1 plus, means this sigmoid function output will be I will explain you why it is 0 or 1. 1 plus e raised to 0, right? What is e raised to 0? 1 upon 1 plus 1. So 1 by 2. So 1 by 2 is 0.5. So here I got the output as a 0.5. Suppose I am taking x is equal to 1. Then 1 upon 1 plus e raised to minus 1. So it is equal to 1 upon 1 plus 1 by e. What is value of e? It is 2.3, 2.73 or something. So 1 upon 2.73, the value will be, let it be 0.3. Let it be. I'm not calculating. So 1 upon 1 plus 0.3. So what answer you will get? The answer is 1 upon 1 means something 0.7. So you will get some fraction values, and those fraction values can be converted into 0 or 1 based on less than or greater than 0.5. If the value is less than 0.5, you will make it as a 0. If it is value is greater than 0.5, you can make it as a 1. Hence, I am telling the sigmoid is giving output as a 0 or 1. Output as a 0 or 1. So that is nothing but activation function. Whatever summation you are performing, that summation will be given to the activation function, and activation function will give the output as a 0 or 1. What is need of bias and weight? And bias. Now, what is a weight? So weight means your input is multiplied by some number. Multiplied by some number. So if this is neuron, you have x1 and x2, only 2 I am taking x2, and w1 and w2. So if there is no weight, so what is need of a weight? That is my question, and I will give the answers as well. X1 multiplied by w1 and x2 multiplied by w2. Why we are taking weight multiplication? So sometimes what happen, x1 is so large, suppose x1 is so large and x2 is very small, like 1001. 1001. So who will give the effect over the output? If suppose 1000 plus 1, so it is nothing but 1001, right? Addition if we perform. So who is having the more effect over the output? The first quantity, which is very much larger. So it will dominate the output. It will dominate the output. So how we can balance it? How we can balance it? There is a way to balance it, is nothing but multiply with some number. Suppose 1000. If you multiply it by, for example, 0.3 as a weight, this is suppose w1, it is x1, and 1 is you have to multiply it with 10 or 20, w2. Now perform the operation. 1000 into 3 means it will come to 320. So answer will be 320. Here you will find the effect of both the inputs because we have added the weights, and as we can change the weight, we can different or we can vary the effect of inputs, right? And because of that, weight is important. So you can vary the weights, and based on that, your effect of an input will be varied. So this is nothing but how weight is important. Now what about the bias? Why bias is important? If suppose this output will be summation of xi wi plus bias, right? So if suppose in some cases weights is equal to 0, generally initially in deep learning models we are initializing the weights with the 0. So if we initialize with the 0, output will be 0 plus output will be 0 if there is no bias, and this output doesn't mean anything. Always it will remain 0. Why I'm telling this, it is very important. Okay, very important, try to understand. And I know that you cannot understand more than 5% or 10% because the same experience I have. But today I can tell you many things about the deep learning because I have worked over the deep learning. I have made some iterations over it. Not a single iteration. In a single iteration I understood. Just don't get confused. Don't be afraid of this. It is very easy. Yeah, I'm telling you, very easy. But what is required? You require the repetitions. You require iterations. Now, the my main motto of this is how weight and biases are important. Suppose this is the perceptron we have. We have input as x1, only two inputs I am taking, and suppose it is x2, and there may be output y, correct? So, what this particular perceptron will do, it will multiply, means it will have input x1 generally multiply by weight 1 and x2 multiply by weight 2. If suppose there is no weight, for example, weight is not available, this quantity will become x1 plus x2. For example, x1 plus x2. If x1 is so large, means if suppose the value of x1 is 1000 and x2 is only 2, x2 is 2. So if you perform addition, it will become 1000 plus 2, so 1002. So here you will find this 1000 having more effect. It is the main component of the output, because which is suppressing another, like 1000 is suppressing 2. But how we can have the importance of every input, because even small input can trigger many things, so how we can add or how we can improve the or increase the importance of the second output is nothing but by using the weights. So weight is nothing but the some number we are multiplying with the input. So for example, here I have weight 1 and I have weight 2, and weight 2. If I multiply weight 1, for example, my weight 1 is equal to zero point 0.3 and weight 2 is equal to 30. Weight 1 is zero point 0.3, weight 2 is 30. Now do the operation again. X1 multiplied by W1 plus X2 multiplied by W2 is equal to X1 is 1000 multiplied by 0 0.3 plus X2 is 2 multiplied by 30. Now the first value will come as 300 plus next is 60. Now you can see the second input is having an importance now. 60 is not very less. 60 is not that much that you cannot neglect. You can make here that 1000. Yeah, I have 1000. If suppose I want to give you 1005 rupees. Okay, 1005 rupees to you. Sometimes what happens, I will make, yeah, you can say that, yeah, you can give 1000. So similarly, at that time, what happens? Input one having very more importance, or it is suppressing the other input. It is suppressing other input. But how we? Because in case of a model training, our all inputs are very important. All inputs are very important. In machine learning also, you have applied this concept like standardization. You have heard about the concept normalization. Because what is the purpose of standardization or normalization? You have to make all inputs equally, are all inputs important? Because if suppose one input is 1000, 1 lakh, and one input is 0.5, there is no comparison at all. But if those two are very important in case of prediction, in case of training the model, you have to make the equal, or try to make the importance of both, and that importance is added by the weights in this case. So weight, because of that, you can find the second input also become important. So this is the first thing we have, why we want a weight. Now next is a bias. What is the need of bias? We know that the formula is summation xi wi plus bias. Suppose initially, most of the times in the deep learning models, we are initializing weights as a zero. Most of the times, most of the times, or sometimes you can say we are multiplying, means initializing, because initially there is no weight in the model. Whenever you are designing, for example, whenever you are designing any car, the whether the car will have the petrol initially, how petrol will come if you put the petrol inside that, otherwise it is empty, the tank will be empty. Similarly, whenever you have a model, initially the weights will be zero, so that if initial weights are zero in both the case, what is the output? 1000 multiplied by 0 is 0, x2 means 2 multiplied by 0 will be 0, so summation will become 0, and this will repeat because we have to update the weights. Actually, in deep learning, what we are doing, we are updating the weights based on the training. So if it is 0, then the weights will not update in the training. Weights will not update in the training. So to do that, if suppose I am adding something as a bias b, bias means any number. If suppose I am adding as a 5, or if I am adding as a 2, then that 2 will definitely try to update the weights in the back propagation. There is a concept forward propagation and backward propagation that will be explained later. So generally what happens in the neural network in general, if suppose this is a neural network, okay, it has many perceptron and all. In the forward propagation, you are having a suppose data, you are trying to train this model. Then in the backward propagation, based on the error, you are trying to update the weights, you are trying to update the weights. So in case of training, deep learning training means what? Deep learning training means you are updating a weights and bias by providing the data, and based on the data, weights and bias will be updated.